All right, YouTube. Today we are talking refrigerator diagnostics. And here's what I'm going to show you guys. It's an older model GE refrigerator, side by side. People who owned it were going to throw it away. Said they think it lost its Freon charge. It wasn't cooling anymore. It worked for a couple weeks, and it just got hot inside the cabinet. And I said, well, let me look at this thing first. Now, I prefer these old refrigerators to the new ones because there's no computer in here. There's no electronics. It's all mechanical. You got mechanical timers. You got mechanical temperature switches that either open or close. And, it's mechanical. Mechanical is always better than digital. I'm sorry. Somebody might argue with me that fact, but you know what? There is no logic board to fail here, okay? We got a timer up in here, and we got, one other component that can fail in here, and, two other components. Well, three components. I'm going to go over this with you, okay? Here's what I'm going to tell you. You got a fridge. It was cooling fine. Now it's not cooling. More than likely, your coil is going to be slap packed full of ice. It's going to be frozen up. Now, here's how you're going to diagnose this. One, the most obvious thing ever is your fan running inside your cabinet? This is a very normal noise. It's always in the freezer section. If you don't hear your fan running, that's the first thing you need to replace your fan. Okay, let's say fan's running. What's next? Well, the other cause is let me go over the causes. I'm trying my best here, people. All right, so you got your fan. Fan's not working. If it's not the fan, is your compressor running? If your compressor is running and you can touch it and it's hot, okay? If there's no Freon, generally they'll be warm to the touch, but they won't be hot. If it's hot, then you have a Freon charge, and yeah, you're good to go. Okay? So your fan's working, your compressor's running, it's still not cold inside. Chances are this coil is packed full of ice, and the air is not traveling from the bottom up and around. Here's the circle right here, guys. This is how it works. Okay? And when this is packed full of ice, ain't nothing working. So here's what you need to do. Okay, we got our defrost timer up in here. I'm going to try to zoom in. Okay, that's what it looks like. It's not always in the same spot, but this is what it will look like from the side that you can see it now. I don't know if you noticed, but there is a mark right here I put with my pen. I want to make sure that this is turning, okay? So when I plug this refrigerator in, see how that slit is right there? That's where you can put a flathead screwdriver. You can only turn this one way, okay? When I plug this in, that lined up with this. So I put a mark right here. I wanted to make sure this timer was turning. If this timer is not turning, then it is bad. It needs to be replaced. Now, on the other hand, now this is very, very rare. Okay, I want to express that. It is very, very rare that this timer will still turn, but be bad. And what I mean is, let me get a screwdriver. Okay, I want you to listen carefully. When this thing hits defrost mode, a set of contacts will close that allow the defrost heaters to work. Now I want you to listen. This is normal operation clicking. Normal operation clicking. You hear that? That was the contact closing for the defrost elements. Now, I have seen those contacts be so burnt up that the defrost elements don't work, but that is super, super rare. Most cases, that timer is not turning, needs to be replaced, and that is the most common cause of your refrigerator going bad. Now, let's move on to the second most common cause. So, let's say your timer's working good and your fridge ain't working. Now, how can I check that without having to open up my whole cabinet and see what the problem is? Well, let me show you that. This is very cheap. It's at Harbor Freight. It's called a clamp meter. Okay, this measures amperage draw. You see right now I got my shop lights on, and this is the amperage they're drawing. Okay, I have my refrigerator plugged into this box. Okay, normally running it's drawing like 2.3 amps. And a way you could do this would be to get a short extension cord. Okay, carefully cut off the outside jacket, the orange jacket, green jacket, whatever color extension cord you buy. Cut off the outer jacket. Do not, and I know it's ridiculous I have to say this, but do not do this while it's plugged in. And cut off the outer jacket. Do not cut the inner jacket of the wires. And the one that you want to clamp onto is the black wire. You see that? I got my clamp meter around the black wire. That's going to measure your amperage draw. Okay, like I said, when the compressor's running, the fridge is running normal, this is drawing like 2.3 amps. Now, whenever you just heard that click in here, when it shuts off the compressor and goes into defrost mode, this meter should read about 10 amps. 10 amps. It draws a lot in defrost mode. You got, in this case, this refrigerator has 2 coils that are drawing, and it draws some amperage. So that is a quick test to see if your defrost system is working, if your timer switch is good. Okay, so I checked the timer switch. It's rotating. It's good. I advanced it to the click. I read my amperage gauge. I had no amperage because at this point, the compressor's off. So it's not drawing anything except for the wattage of the light bulb being on. So I knew I had a problem. So I went ahead. Now that's how you can tell if there's a problem before disassemble. Now we disassembled. Let me show you what the problem is now. These right here, see if I can move these wires. Do you see this guy right here? These are always up at the top somewhere. This is your defrost thermostat. It's not always necessarily red. Usually they're black. Usually when they fail, that potting compound they put in there will bulge out. It'll fail. An easy way. Well, let me go this way first. All right. So you need to visually inspect your elements. Okay. Sorry about the camera autofocus. Visually inspect your elements. What I did was I pulled. There's 2 of them in this fridge. There's one on the bottom, one on the top. This one came out of the bottom. As you can see, is completely burnt inside this tube. This element is no good, needs to be replaced. Then, this is the top element. This is what they should look like. You can see the coil cleanly inside there, but if you go over to here, you see all that rust and crap in there? It had a failure. This one had, I'm guessing this seal failed. The moisture got in there, corroded the contacts, and this one's not working either. So, this is the cause of this refrigerator not working. This refrigerator, this coil, after 3 weeks of running, this whole thing becomes a solid sheet of ice, and there's not going to be any airflow. The air is not going to make this path like it should. You know, and it's the same for the upright freezers. You got a coil from side to side. It's the coils don't look like this. They kind of look like a miniature oven element, but they're still along the bottom. They still got the defrost thermostat up there at the top, wherever the pipe goes in. If it's up there or up there, they're usually clamped up at the top, and you know, that controls this. So if you check these and they're good, and I mean by check them, okay, you take your ohm meter, okay, and you put your lead over here, you put your lead over here, and it shows that you have contact between the two, then your element's good. It's real simple. It's yes or no. Does it have contact? Yes or no. If it does, if you pull your elements or you check your elements and they have contact and it's good, then the last piece of the puzzle is that defrost thermostat. Now, a lot of people sometimes will check that and they'll say, oh, it's no good. If I was to pull this off right now and check it with my ohm meter, it would say that it's bad, that it's not closed. It's not letting the electrons flow. And that's because those things do not close until, I want to say, safe zone is negative 10 degrees. I'm sure somebody might say I'm wrong, but let's just say an average is 10 degrees. That switch will close at 10 degrees. It will not open again until it gets to 20 or 30 degrees. And that allows the electrons to flow.